Hi, I'm Luisa Gomez, a master's student at the Universidad Nacional de Colombia. Tree mortality is a complex ecological process that results from a combination of non-mutually exclusive factors that operate at individual, species, and stand levels. Here, we assess the influence of tree crown exposure to light relative to total crown area, individual deviations of growth rates, tree size, and species with density on the mortality of canopy trees for the Macayacu forest dynamics plot between 2013 to 2019. Since light is a fundamental resource for which trees compete, we expect that trees with higher proportions of their crowns exposed to direct sunlight will die less compared to more shaded trees, and this effect will vary with tree size, growth rates, and the species with density due to different life history strategies. This study was carried out at the 25-hectare Macayacu Forest Dynamics plot, which is located in the northwestern Amazon. First, we delimited tree crowns using a drone-derived high-resolution image, a total of 941 canopy tree crowns, and we then calculate their sun-exposed crown area, which is the area that we could see from above. Then we estimate the total crown area using a DBH allometric model that was constructed using a crown survey carried out at the Macayacu Forest Dynamics plot. For each delimited tree, we calculate the relative crown exposure to light, which is the directly sun-exposed crown area, over the total crown area. And this is a continuous metric that accounts for light availability. And this resource is typically measured with categorical indices. Our metric indicates how much proportion of the total investment of the tree in the crown is actually sun-exposed. We calculate a species-adjusted tree growth rates, which is the individual tree growth deviation with respect to his species average, tree size, and species with density, and we explore the influence of these variables on the probability of death of canopy trees in 2019 using generalized linear nexus models. We found that the mortality model with the lowest ICACI information criterion include relative crown exposure to light with density, species-adjusted growth rates, and their second-order interactions, and the main effects of these variables plus the interaction between relative crown exposure to light and with density were highly significant. As our main result, we found that the probability of death was influenced by the two-order interactions among wood density, relative crown exposure to light, and species-adjusted growth rates. For trees of species with low wood density, relative crown exposure to light was negatively related to the probability of death during this 6 years time period, as also did species-adjusted growth rates. This means that the survival of trees with low wood density depended on both having large proportions of their crowns exposed to direct sunlight plus growing more than their species average. And this is in line for light-demanding species which typically have low wood density and which require high light requirements due to their high maintenance costs. By contrast, we found for trees of species with high wood density, we found that relative crown exposure to light was positively related to the probability of death, but was not dependent of species-adjusted growth rates. This means that the survival of trees of species with high wood density decreased as light availability increases, and we propose that this group may be conformed by shade-tolerant species which typically have high wood densities. And we propose that the increase in the probability of death as light increases was probably caused by an abrupt increase in light, which probably caused leaf stress and photoinhibition, plus an abrupt increase in evaporative demands. And these changes are typical with gap openings. We conclude our results indicate the importance of the inclusion of plant functional types related to life history strategies. For example, in this study, we did it here by wood density, and this will help us to better predict forest demography under ongoing global changes. Let me know if you have any questions. I will be glad to answer you.